Okay, good day, class. We're going to be looking at lesson 2 in our book here, and we're introducing about hardware. Now, in lesson 1, we learned about just introduce us to what computers were about and the history of the computers. And so today we're diving in a little bit deeper as to looking at how this hardware is being utilized, and then we're going forward from there. All right, so here in this introduction, we're looking at our objectives here, and there are 4 objectives in this lesson. First of all, it's going to describe the main parts of the computer hardware system. It's going to summarize the operation of each hardware component. It's going to evaluate the significance of each hardware specification, and then to determine which hardware system works best in your situation. All right, so outlining this chapter, we're looking at the understanding of computer hardware systems. We are identifying hardware components. We are going to be assessing hardware specifications, and then choosing a suitable system, and then the summarization. All right, so let's dive right in. Understanding the computer hardware system. Remember that every computer has both what's called the hardware and the software. The hardware is everything is electronic, everything that's like, for instance, the monitor that's on your screen, the keyboard, everything that has to do with going to bring information into the computer. All right, so you have the inner workings of circuits, electronical circuits that are part of the main frame of the computer. So we see here where it says that the hardware is the term used for the physical part of a computer, what you see. So those are the things that you can see. All right, so you can see again the monitor, the screen, the keyboard, the mouse. You can see the different components that are there for you to input information into the computer to get information out. All right. So as it says here, as well as the electronic circuits inside. So it's not just the physical things that we see on the outside, but it's also the electronics that's going on the inside of the computer that fires off messages back and forth, so that you're able to understand or you're able to transmit information, and it's able to give you back information also. So although some computing devices, such as the 4-function calculators, use only hardware, most modern computers contain both the hardware and the software components. All right, so every computer has a hardware and the software. So today we're just going to be focusing on just the hardware. All right. So it says here, continuing, that this is certainly true of all modern computing devices, as we discussed in lesson 1, and you will explore the maze of hardware components in this lesson before beginning unraveling the mysteries of the software in lesson 3. All right, so then we're talking about the hardware system provides the physical framework or the infrastructure. And infrastructure is the foundation or the underlying elements of a system. So this is the physical framework or the physical infrastructure for the computer, the human interfaces, the electrical interfaces, the storage for software programs and data, and main computing circuitry. The three main elements of the PC hardware systems are the physical infrastructure, the computation circuitry, and the peripheral devices. Let me repeat those three things again. There are three main elements of the PC hardware system, and there are the physical infrastructure, the computation circuitry, and the peripheral devices. And we're going to explore each one of those now. All right, so first of all, the physical infrastructure. What is that all about? Well, as you know that there is the input and the output connectors and the power source. All right, so a computer's physical framework consists of a chassis, and a chassis is the mounting or supporting structure for the components of an electrical devices. All right, so this physical structure has an inputs and an outputs, or what we call the I/O connectors, and the power source. Manufacturers often design the desktop PC chassis to accept plugins, devices, and other parts the user wants to choose later. For example, each computer not only has a part for you to plug into your wall, but it also has the ability for you to add other things. You know, like if you're going to charge your phone, it has that component, that device that you can use that looks almost similar here, without plugging anything out. Yeah. Okay. So it looks similar. Where is it? Similar to something like this. All right. When you plug a USB cord or in the USB port, these are also input devices. So at the back of the computer or on the CPU unit, you'll have a place for you to plug a device like this in, and so therefore you're able to access information from your device. All right, so the input is the term for electrical signals that come into the computer, and the output describes those that go out from the computer. All right, so these signals are, they exit and they enter the chassis through the I/O connectors. All right, and those are the input-output connectors. Sometimes they're called the interface connectors, all right, which carry to and from messages to and from external devices. As for power, the chassis of the desktop or PC server has a high wattage power supply that changes the normal power line voltage to specific voltages required by the computer for internal peripherals. All right, so we have, again, these are your devices that you attach to the computer that allows you to input information. For example, your keyboard would also be attached to the computer for you to enter information into. The mouse would be attached to the computer for you to enter, for you to manipulate data so that you're able to do what needs to be done. So not only do you have the internal peripherals, but you also have the external peripherals. And these external peripherals, as we're looking at this diagram here, it says while the keyboard and the display are separate from the chassis of a desktop PC, these two components are included in the chassis of notebooks and tablets. Tablet PC, a notebook or tablet PC also contain a rechargeable battery and power management circuitry that converts the battery voltage. And again, it reserves energy or voltage, especially in a notebook or a tablet. Unlike the PC that you have to plug in, and whenever you're not using it, you exit out and then you plug out the computer. Once you plug out the computer, there's no way for you to access information on the computer. But with the tablet or your notebook, as long as you have a battery charge that has voltage in there, and it's reserved in there, your notebook and your tablet are able to be utilized without the use of plugging in to a power source. All right, so now the computer, what does that mean? Often the word computer refers to a computer chassis and everything in it. However, in this lesson, just in this lesson, the term computer refers to the computing circuitry that includes a microprocessor and its memory and electrical interfaces. Don't get bogged down by these terminologies. This is just, again, this is introductory. So this is just giving you a brief overview of this thing. So we're not going deep into what the microprocessor does or the electrical interfaces and how things are connected. This is just for informational purposes. All right, so don't get clouded with this information. These are contained on a printed circuit board called the motherboard. And the motherboard is usually in the CPU, and that's where all the information is being rallied back and forth, okay? And so it's mounted within the chassis. In the desktop PC, the motherboard usually includes extra connectors to allow for the addition of more memory, expanded electrical interfaces, and other peripherals. Okay, those will be discussed later in this lesson. All right, so what are peripherals? I wish they had a picture here to show you what they were talking about, but we'll try and find some picture. All right, so again, we're talking about the computer, we're talking about the hardware system, and we're talking about all the components that goes into us accessing information on the computer. Remember, when you have a computer, you not just have the shell of the computer and the hardware part of it, but you also have the software part of it. And as again, today we're just dealing with just the hardware, all right? Because you can't access information properly without both interfacing or connecting or firing off messages to each other, okay? Both has to be there. You have to have both the hardware as the framework, the structure that that is able to carry the information, and then you have the software that are these different programs that are placed in the hardware that allows you to get into a Word program or into an Excel program or a PowerPoint program or a music program or a video program. All right, so all those are softwares. All right, so we're talking about the hardware. Okay, so whether inside or outside the chassis, peripherals increase their computer capabilities and or provide human interfaces to the system. Modern PCs include several internal peripherals that are considered part of the basic computer system and are often required for the computer to operate. All right, again, just like what I said. For example, it talks about disk memory is essential before a person can install an operating system or an application program. Again, just like what I said, that you need your hardware, so the hardware has to be there, and then the software are the other things that will allow you to have a cohesive flow of information as these are the application programs. These are the programs that are going to now give you what you're looking for, whether again it's a Word program or whether it's regarding statistical data that you have to use Excel for, or a PowerPoint for graphics to display to other persons. All right, common external peripheral devices includes, these are the external now, includes the keyboard, the mouse, the disk drives, the monitor or the display unit, and the printer. And it may also include the scanner, the modem, the flash memory devices, the fax interface, the webcam, the microphone, the speakers. And so you can see that all of these are considered the external peripherals that are attached to the computer that allows you and I to interact with the computer, software programs or application programs that are there, and communicate with other persons or communicate correctly with the units. All right, we're going to be looking at the history of the microprocessor. And this is about identifying hardware components. And it says here that in 1958 to 1959, you had engineers like Jack Kilby and Robert Noyce who invented the integrated circuit, or the IC, which allowed multiple transistors and other electronic components to be placed on a single piece of silicon material. Again, as we said last week, that most of the time, well, at the beginning parts of the history of computers, it took up an entire room, and they had perfected the science over time to where now it's just a little piece of silicon, a rectangular thing here that they just insert into one of the pockets in the CPU unit, and now that allows information to be transferred back and forth as it's utilizing the electronic impulses and stuff like that to fire off messages and things of that nature. So since the 1960s, improvements in manufacturing technology have allowed an ever-increasing number of transistors to be placed on a single IC chip, the integrated circuit chip. And that has been doubling over the years, and now, you know, we're able to, as again, the chips have become smaller and smaller in size, and so you know, now we are moving information much more rapidly than we did back then. Again, it used to be the fact that 18,000 vacuum tubes and 8 by 8 by 100 feet of ENAC back in the 1949 were utilized just to get one little piece of information. And now, again, we have these microprocessors that just fire off information quickly and quicker, to the point where, you know, you don't have to wait for a long time for the computers to spit out information. All right. So the role of the microprocessor, to understand the operation of a PC, we must consider only the operation of the microprocessor that serves as a CPU for the system. So the CPU, the microprocessor, is considered the brain of the operation. Okay, so as the brain of the CPU of the PC, the CPU microprocessor performs the work the software programs require. So it starts to connect things together. Again, if you're doing a Word program or typing something in Word, it will send the messages to the right places, so that you're able to, so that the computer is able to now do what you have desired for it to do. All right. Okay, so it says here, as the brain of the PC, the CPU microprocessor performs the work of the software programs, what the software programs require. All other microprocessors in the PC, such as the graphics, the video, the communication processors, are also co-processors. Okay, they're co-processors and are always under the control of the main CPU and its software. All right. And I think that's kind of explanatory there. I don't think I have to go over that over and over again. All right, so a microprocessor has several sections, but like the heart is a central processing unit that performs, but at the heart of the central processing unit that performs all the computations, the modern PC microprocessor have additional sections. And all that they're doing is they're interconnecting with the software, and they're connecting with the hardware. And so they're carrying messages or digital information back and forth, so that you and I are able to communicate more effectively. So other microprocessors component include interface logic and high-speed random access memory. I'm sure you've heard about RAM. And whenever someone is purchasing a computer, they want to find out what the RAM is. The random access memory. That means how much memory does the computer has that will handle the amount of software that's being placed into the computer. And so this is called a random access memory. Okay, this on-chip memory enables faster computations. So if the RAM is of a lower class, like 32, you know it's not going to be quick. But if it's like a 64 or 120, then it's going to move quicker, and it won't. Sometimes your computer starts moving sluggishly. Because not enough memory is there, and so therefore it's not able to move as quickly as it needs to do. Okay, the motherboard. Okay, the motherboard is the major printed circuit board within the PC chassis. The motherboard's main job is to hold the computer's microprocessing chip and let everything else connect to it. And as you see here, a picture here of the microprocessing of the motherboard. If you were supposed to open your computer, the CPU unit, you would see exactly this layout here. This is the motherboard. This is where all of these little circuitries here are, where information is being stored, communicating with each other. Up here is where, right here in the slot here, is where they will put that RAM memory thing here to increase the flow of information as it's going back and forth. Things here would connect to the printers. This is the command center. This is the motherboard. This is the command center. This tells the computer what to do, when to do, how to do, what needs to be done. These are where you would connect your USB and your telephone jack to it. This is where you connect your sound ports and your video ports. These are over here your USB ports. So if you had other devices, external flash drives or stuff like that, you would use these external ports here, USB ports, to have access to the information that's on the flash drive. All right. All right, what is memory? Oh, we know what memory is. Memory is the ability to retain knowledge. All right, and so the process, as it says here, memory, it describes memory as the process by which people and other organisms encode, store, and retrieve information. So encoding refers to the initial perception and registration of the information. Storage is the retention of the encoded information. That means when we type something and then we save it, it's retained for your retrieval, or stored for your retrieval at a later time. And then retrieval refers to the process involved in using stored information. So that's when you save your information in your Word program, and then you save it as information technology class, and then it's stored in your Word program. And then when you want to retrieve that information, you just go into your Word program and go under the file to open the file, and then you just search for computers, or whatever you called it, and then it will bring up back what you have written and stored. All right, so like the brain, the computer's CPU encodes, it stores and retrieves information. However, the computer encodes information in binary numbers. That means it's a digits of zeros and ones. So it uses these binary numbers to save the information. There are two basic types. You have the volatile memory devices, and then you have the non-volatile memory devices. So the volatile memory devices lose their contents when the power is turned off. So, for example, have you ever written a file and you did not press save as you were typing it, and then the power went off, and then you lost all of that information, then you have to retype everything all over again? That's the volatile memory device, that it will lose the contents as soon as there is no power. But the non-volatile memory device, it can retain and store information even when the power is off. And so back then you had the volatile one. Nowadays, the newer computers have the non-volatile memory devices that is part of the memory board, motherboard there. And so it retains the information stored even when the power is turned off. Do you notice that when sometimes when you are writing a document in your Word program and the power goes off, and then when the power comes back on, and you go back into the Word program, it will say, okay, you did not save this information, and it pops it up and said, so in order for you to continue working on it, you'll have to open it back again and save it as what you want it to be saved as. All right, so that's what that's talking about. So it's always important that whenever you are writing a document, that you are saving your documents. All right, so here it gives you the non-volatile memory devices. These are the read-only, the ROM memory, the programmable read-only memory. Then you have the flash memory, the hard disk, the floppy disk. We don't use floppy disk anymore. Oh Lord, that's way back, floppy disk. CDs and DVDs, we hardly use those anymore. Everything is really flash memory that we do use. And the magnetic tapes, oh boy, that's really way back. All right, and then the volatile memory devices are your random access memory, or RAM, your dynamic random access memory, and the static random access memory. All right. Okay, and then this part here just goes through about other memory classifications, so I'm sure you can read that. Again, don't get bogged down with the reading of these types of material. Just read for understanding, and it's not like you're going to have to give a dissertation on this. Again, this is just telling you about the different uses of those memory things, devices. Let's go into interfaces. Why are interfaces important? All right, so according to the Microsoft Encarta dictionary, it defines the computer interface as a common boundary. Where is it? A common boundary. A common boundary shared by two devices or by a person on a device across which data or information flows. All right. So hardware interfaces are the plugs, the sockets, the cables, the electrical signals traveling through them. Thus, the selection of interfaces on the PC is defined by the specific active connections available on the computer chassis. So if your connections are not plugged in properly, the power flow, the electrical signals can't go to fire off messages to go to the hardware. So you have to ensure that these cables are put in correctly so that you get the right information and your computer can work properly. All right. With a notebook or a tablet, you really don't have these kind of things. It's only with the PC. All right. And we all know about Bluetooth. Okay, it says here, down here. Okay, it says wired interfaces available on most PCs include connectors to the mouse, the keyboard, speakers, microphone, headphones, printer, video projectors, and any other external devices, the phone line, the power line, networks, and so forth. Anything that connects the PC by way of wire. For wireless connections, individuals commonly use Bluetooth or Wi-Fi interfaces. And the Bluetooth, that's a low power, short range radio frequency for wireless networking of personal devices and peripherals such as a cell phone and computers. As you know, that most of the things that are created now are created with the Bluetooth capacity. And what that means is that I don't have to worry about the wires anymore because now I can do it without the use of wires. Okay, so when you have the headsets that are Bluetooth, that you don't have that wire coming down and getting tangled up on you. So it's going through a radio frequency, communicating with the PC or with the telephone or with your notebook, and so you're able to interface with it anyway without the wire. Okay, so that's what the Bluetooth is all about. All right. Peripherals, how do peripherals enhance PC operation? As we noted earlier, peripheral devices is a term for anything outside of the CPU section of the microprocessor. However, modern use of the term peripheral generally refers to any device or electronic circuitry external to the motherboard. In this sense, expansion cards added to the motherboard, such as memory cards and interface adapters, are expansions to the motherboard and therefore do not fit the definition of peripheral devices. So peripheral devices can either be internal or external. And so the internal peripherals are devices inside the computer chassis. Okay, so you can increase memory in a computer, and that's the internal peripheral. Okay, so you can increase the memory of a PC. So in the PC desktop, this includes the hard disks, the CDs, or DVD drives, floppy disk drive, which we don't have anymore, and so forth. In a notebook or laptop, internal peripherals include display, monitor, keyboard, and pointing devices as well. All right. We all know about these input devices, the keyboards, the mouse. Everybody knows what the mouse looks like in the notebook. There's no mouse that's included, but you can include a mouse if you want to. But they usually have the touch pads that are again Bluetooth, or you can use your finger across the screen in order to do stuff like I'm doing with my iPad right now. Let me show you. Yeah, so I'm making lines here by just using my finger. All right. You have your optical scanner, and these scan images, printed text, handwritings, or objects that convert them into digital image. Most PC scanners are known as desktop flatbed scanners. Okay, so these are the scanners that we use. These are optical scanners or optical stuff that's used to transfer digital images to our PC, and they are stored on the PC in this format here, in a JPEG, TIFF, BPM, or PGN. So that's what the pictures are being saved as on your device. Okay, then you have your microphone. You know what the microphone does. You know what the webcam does. So all of these that we just mentioned here are part of the input device. So you have your keyboards, your mouse, your optical scanners, your microphone, your webcams, right? The output devices would be your computer monitor. All right, so you're watching me on your monitor or the screen that displays the information. So that's your monitor. That's an output device. Another output device is your printer. We all know what that does. That just prints documents, pictures, and stuff of the sort. And you have your desktop printers, and you do have your inkjets, or that they have increased those inkjets to those laser printers nowadays. Then you have your digital projectors. That's another output. So you can display whether you're teaching a class, whether you're doing a worship seminar, with your PowerPoints or your illustrative messages and stuff like that. You use the projectors. You also have your speakers and your headphones that are used, especially when you're doing a Zoom session or you're doing a voiceover or stuff of that nature. Then you also have another one is the memory devices, where you can have an external hard drive that instead of saving information on your computer, you can have a hard drive. I think I have one here. Yes, here is my external hard drive. This is 1 terabyte. So this holds more information on here than my computer. So if I want to save information without cluttering my computer, I have an external hard drive. Okay. You also have your flash drives. But that's also limited in terms of how much data it can store on there. Mostly if you're putting music files on there or video files, it tends to eat up more of the memory. So so you probably use an external one that has terabytes, which is much larger than gigabytes. And, yes. So here are pictures of these SD cards that we've used, especially with our headphones, the Bluetooth headphones to listen to music. Or here's a example of what a USB flash drive looks like. All right, I think lesson 2 here is a little bit self-explanatory from what I'm looking at here. All right, so assessing hardware specification. Okay, in the final section of this lesson, you will learn how to evaluate the specification of a PC and its peripheral devices, and how to relate these to your situation. Okay, although the technical details may be difficult to grasp at first, as you become familiar with this information, you will better understand what type of PC is best for your individual use or your ministry use. So again, please do not allow yourself to get so cramped down with this or boggled down with the information that you get discouraged. Just press through this. All right, the personal computer hardware. Again, this is self-explanatory. You have your number of CPU cores. This has to do with the microprocessor specification. So you have your number of CPU cores, as it says here. And that is the multiple cores allow the microprocessor to carry out multiple instructions at the same time, increasing the speed at which programs can run. All right, so this is about the speed of the computer. All right, so you want to make sure that whenever you're purchasing a computer, that it's at least 64 bits, right? Because then it will carry out the information quicker. 64 or higher would be the best. Okay, then the clock rate. The clock rate is sometimes called the CPU. This has to do with the speed or the microprocessor speed. Again, in the newer models, PC models, it's usually 2.0 gigahertz or 2.30 gigahertz right here. This has to do with the speed. So this one has to do with how the information is being carried. The 64 bits is important, and the other one is about the speed. Both of them work hand in hand with each other. Then you have amount on chip cache memory. So this is about how much memory is stored and on the CPU. Okay. Then the speed of the external bus. Again, all of this has to do with all of this microprocessing data here has to do with one thing: speed. How quickly information is is sent back and forth. All right. Okay, so take your time to go through these one by one. Again, just read through them just for information purposes. Not, again, you're not doing a dissertation. You just need to get an overall understanding of what it's all about. External peripheral devices. How do the specifications of external peripherals affect the PC operation? Okay, the speed of the hard disk drives can directly influence the PC's performance. Again, we've been talking about speed and how that is important. So it can affect the performance. Other peripherals have less efforts on the actual PC performance and more effect on the functionality and user perception of its operation. So there are only few key specifications to evaluate for each peripheral to determine its usefulness. So they list down here the ones that you need to look at. You need to look at the computer monitor. Make sure that it's the resolution, the size, and the ratio is good. You want to look at monitor size. It's usually measured diagonally. Typically, the sizes are 13, 15, 17, 19, 21 inches. There are others that are larger. So you have up to 37 inches wide. All right, you can even have larger than that. So but that has to do with the monitor size. Okay, the aspect ratio is the ratio between the monitor's horizontal dimensions and the vertical dimensions. That is the horizontal dimension divided by the vertical. So common monitor aspect ratios are usually 5 to 4 or 1 to 20.25. All right, so this is the important stuff. Resolution, that has to do with the pixels. How clear your picture is. And the widescreen, again, has to do with the resolution. And so you want to be able to do those things. Then you have your CD, DVD optical drives. You should know about these already. Your printers, you should know about that, how that is, how that functions. You should know about digital projectors, how that it's about brightness, resolution, projection technology type, and portability. Portability means how easily you can transport it from one location to the next. All right. All right, and then you can read through this on your own, choosing a suitable system for yourself. And what does that mean? And how to maximize on things. And here are some general things that they have here for you to look at whenever you are planning on purchasing a computer. Okay. All right, I think that's it for lesson 2. Yes. All right. And then I will send you the quiz for lesson 2. And then you'll be, I'll probably send it to you by Monday. I was supposed to send it off today, Friday. The time that I'm recording this, it's really Saturday morning. But I'll give you some time, and I will send off the quiz on. I'll do it Sunday evening when I get back from church, so that you'll have it then. So it gives you a chance to go through lesson 2 with this video, and hopefully this is working for you. Please send me comments and let me know if this works also, and then we will try and see how we could record our sessions via the format that the school has. I'll have to figure out how to do that. But if this format works, where it gives you extra information, then let's do it this way. Right now I'm using Zoom, and so I'm very versatile with the Zoom, so I came back to the Zoom format here. Well, God bless you guys, and I hope that you are all well and staying strong. And again, any questions, please feel free to send send your questions in the group, so that we as a group can help each other. All right. God bless you. And may the Lord be with you. In Jesus' name. Amen.